Good morning. Thanks a lot for tuning into our latest edition of our Water Issues Talks. This morning we have Britta Belden, who is from the Capital Region Watershed District, just chatting a little bit. You probably heard with Britta as you were joining. I've just been hearing these great things that the Capital Region Watershed District is doing. And the latest thing that I had the chance to hear about is the really wonderful work that they're doing with Como Lake. I remember when I was a kid, and I'm going to age myself a little bit here, growing up in the area, driving down to Como Lake with my parents. And at that time, it was just this gem, Como Park and Como Lake. And it was always really painful to see what happened to that lake over the years with the phosphorus pollution in the lake and, the decline of the lake. And so it's just really nice to see the work that Britta and other people are putting into this lake and restoring it. And so that's our segue into today's talk. Britta is a water resources project manager for Capital Region Watershed District. She dedicates much of her time to Como Lake by coordinating water quality improvement projects, and she's been with the Capital Region Watershed District since 2010 and has also been involved in the district stormwater monitoring. She holds a BS in physical geography and natural resource management from the University of Wisconsin and went on to earn a master's degree in forest hydrology and watershed management from the University of Minnesota. Britta, thanks for joining us this morning. Looking forward to your talk. Take it away.
Great, thanks for the introduction. And as Mark said, today I'm going to be talking about all the work Capital Region Watershed District's been doing on Como Lake and the implementation of our recently adopted Como Lake Management Plan. And I echo what Mark said about Como Lake. I also grew up in the neighborhood, so it's really an honor to be working on this resource. And I think Como Lake is just such a special spot. Everyone kind of has their own connection to the lake, and it's really a neat gem in the middle of the metro. So with that, my presentation, I'm going to start off with providing you a little background information as well as an overview of the Como Lake Management Plan. I'm going to talk about the implementation of the Como Lake Management Plan and highlight some of the 2020 projects we've been working on. I'm also then going to go through our monitoring data results from 2020, following the implementation of a number of those projects, and then dive into some next steps for 2021. And I'll leave time at the end for questions. So to start off with a little background information, Capital Region Watershed District is a special purpose local unit of government. It's 41 square miles in total and encompasses the majority of city of St. Paul, as well as 4 other cities, Falcon Heights, Roseville, Maplewood, and areas of Lauderdale. The southern border of our district is the Mississippi River. We border 13 miles of Mississippi River. There's 5 lakes within our district. And the district itself has some unique hydrology. There's no natural stream channels left. The majority of the district is storm sewer network. So all our drainage occurs through storm sewers. It's highly urban. There's 42% plus impervious surfaces and 245,000 people living within our boundaries. So impacts on stormwater runoff are widely felt because of the dense urban development. So our primary management goal is stormwater management to improve stormwater before it reaches our water resources. So Capital Region is also home to Como Lake, which resides in the north central portion of our district. Como Lake is part of Como Regional Park, which has an estimated 5.4 million visitors a year. So it's a highly used resource and highly visible. Como Lake is also the centerpiece of the Como Lake or the Como neighborhood, and really is a community gathering space for the area. People enjoy the lake for walking, biking, running, non-motorized boating, birding. It's a place that people go daily or multiple times daily. It's just a highly used and valued resource in the community. However, Como Lake has a long history of poor water quality, as evidenced by frequent algal blooms, frequent fish kills, and then strong odors from both of those algae and other decomposition happening. That's often observed when you're visiting the lake. And this poor water quality is largely due to excess phosphorus, which is the primary driver of poor water quality in Como Lake. So Como Lake's monitoring data record dates back to 1984. We have over 30 years of monitoring data. And through that time, Como Lake has rarely met the state eutrophication parameters for phosphorus, chlorophyll A, and Secchi depth for the shallow lake standards. Through our monitoring data has shown actually that the historical average total phosphorus concentration is 173 micrograms per liter, which is about 3 times the state standard. So the lake is listed as impaired for nutrients. It also is impaired for mercury, and then most recently it's been listed as impaired for chloride. Como Lake's size, as well as its volume and its watershed, play a large part in its poor water quality. So the lake is 70 acres in area, and then it has a max depth of 15.5 feet. So it's a very shallow lake. 97% of the lake is in the littoral zone, so it's quite shallow, with light reaching almost all depths, which contributes to dense vegetation growth. The watershed area is 1,700 acres, and so there's a large contributing watershed area, and this results in a high watershed to lake area ratio of 24.3, which means that the watershed greatly affects the water quality we see in the lake. Here is a map of Como Lake's watershed. There's 13 major sub-watersheds. It's all storm sewers that drain to the lake. There's 22 outfalls that drain to Como Lake. So again, all the activity in the surrounding watershed is eventually transported to the lake via runoff and storm sewers. In 2002, in partnership with the City of St. Paul and the district councils, Capital Region Watershed District developed and implemented the 2002 Como Lake Strategic Management Plan, and this was really the first stab at tackling some of the water quality problems facing Como Lake. The plan largely focused on the implementation of watershed projects. So since 2002, there's been over 84 major best management practices, stormwater best management practices installed throughout the watershed. The map on the right, each of those dots represents different BMPs that have gone in. And as a result, there's been a cumulative total phosphorus reduction of 20% by those projects since 2002. However, water quality has still struggled. So in 2019, we began, or 2018, we began the development of an updated plan, the new Como Lake Management Plan, which was adopted in May 2019. And the new plan took a holistic approach to tackling these water quality problems. And by holistic, I mean it considers all the factors, all the variables that influence water quality and the lake's biology. So we're looking at not just water quality, but the plants, the fish, the other biota living in the lake that all cumulatively play a role in the lake's water quality. It's also an adaptive management approach, which I'll get into shortly, but adaptive management mean it's a 20-year plan, but we are going to incrementally improve the lake over time through a variety of different strategies. It's also a plan that's not just for Capital Region to implement, it's for all the number of agencies that are involved in Como Lakes management, from the city of St. Paul, from the DNR, the county, etc., for all of us to kind of have a shared approach for improving the lake over the next 20 years. So what is adaptive management? Adaptive management is a dynamic process that works with the system, and then we adjust the plan as we go, as different management actions are realized in the lake. We adjust our approach to based on the response of those management actions. So the first half of adaptive management is the development phase, where we're doing a condition analysis of the lake, we're setting goals, and then we're evaluating actions to achieve those goals. And then the back half is the implementation phase, where we actually implement those projects that were identified, we work towards our goals, and then we monitor and evaluate the results, and then adjust the plan to based on what those outcomes are. In practice, for Como Lake, our first step was completing the condition analysis, where we evaluated all of the phosphorus sources to Como Lake, both external and internal. We completed in 2017 the Como Lake water quality drivers analysis, where we quantified all of our sources. Next, we set our goals. We worked with our major stakeholder groups. In the Como Lake Management Plan development process, we had two stakeholder groups. First was our public advisory group, which consisted of community members. And the second was our agency advisory group, which consisted of the number of agencies I just mentioned, all contributing input, so we could really develop a plan that considered all the different perspectives and goals for Como Lake to make it more effective in implementation. Through our stakeholder input process, we identified issues, and from that, 5 major themes were presented. So water quality, shoreline and wildlife habitat, recreation, community stewardship, and then agency partnerships. From that, we developed a set of 5 goals, each of which had a number of objectives underneath. The first goal was to manage Como Lake as an ecologically healthy shallow lake. Goal 2 was to maintain healthy shoreline areas that can support a variety of wildlife and contribute to the health of Como Lake. Third is to maintain a variety of year-round recreation opportunities that are appropriate for a shallow urban lake. 4 is to achieve strong, sustained community engagement and stewardship to improve and protect Como Lake. And lastly, to utilize the best science, partnerships, and resources to ensure successful implementation of the Como Lake Management Plan over the life of the plan, which is 20 years. Based on those goals, we developed a number of actions that will work toward achieving the objectives each underneath that are nested underneath each of the goals. So a recommended action is an actual project or plan to that work toward those objectives and ultimately and cumulatively achieve those 5 goals of the plan. In total, we developed 54 recommended actions for the entire 20 years of the plan. And those recommended actions were underneath the categories of in-lake management or lake management, watershed management, or community-based projects. And then lastly, for implementation. So we, as part of the Como Lake Management Plan, we developed what we call a short-term implementation plan. So this is really the primary tool of the adaptive management planning process because it's a 3-year plan of management actions that are defined. And then this is something that we will redevelop every 3 years and adjust it based on how the lake responded to the actions that were implemented on the previous 3 years. So this is a great way to kind of account for the uncertainty in our expected outcomes. You know, we have our list of recommended actions and we have our best laid plans, but at the end of the day, Como Lake is a living and breathing system, and we need to account for that uncertainty on that the lake is going to respond how it wants to, even if we're using the best science to plan these projects. This also helps with the knowing a little better understanding of the timing of projects, costs, funding, who's leading the effort on this short-term basis. So it's been a really useful tool for keeping projects moving, and also, you know, we didn't just develop a plan and said, you know, here's a cookbook of things we need to do over the next 20 years. This really kind of drives the process and helps us work with the system to hopefully by the end of the 20 years, we'll have done everything within the plan and more, and reach all of those goals on kind of this time-paced way. So, all right, well, with that, we'll talk about, let's get into the fun stuff. We, in 2020, even despite COVID, we were able to really start in on our short-term implementation plan head on, and we tackled a number of the projects that were identified in our first short-term implementation plan. They're all listed here, and I'm going to go through each of these briefly and touch on them, and then head into the results. So first is our annual lake monitoring program. And monitoring data really is, you know, it is critical for adaptive management, but it's also the foundation of our plan, because without monitoring data, and Capital Region in general, we have a really strong monitoring program and utilize our data to make science-based management decisions. So the lake monitoring is particularly important for that. On Como Lake, we have a very comprehensive monitoring program, and that covers chemical and physical monitoring, biological parameters, as well as stormwater and what's coming into the lake. We work with the county to do bi-monthly water quality samples, sampling April through November, that covers a wide suite of parameters. We also have 3 multi-parameter sondes that are continuously collecting dissolved oxygen, temperature, pH, and specific conductivity in the lake. Those are attached to the buoys as seen in this picture here. They're all set in the hypolimnion at the lake bottom. And then we also are continuously collecting water level data with 22 storm sewers attached or draining into the lake. You can imagine the lake's actually quite flashy and bounces significantly during rain events. So that level data has been really useful for kind of understanding lake response to precip. We also monitor the aquatic plant community in the lake 3 times per growing season. We monitor the Turian, the curly-leaf pondweed, which I'll talk about in a little bit. We also monitor phytoplankton and zooplankton in the lake. And then we have 3 full water quality stormwater monitoring stations at outfalls, major outfalls draining to the lake. And those take samples during rain events for a variety of parameters. The second project we implemented in early 2020, and we began work on this in 2019, was the development of a long-term aquatic vegetation management plan with the goal to restore and enhance the native aquatic plant community. Como Lake has an invasive species problem with dominance of curly-leaf pondweed. So the first goal of this plan is to control our invasive. And then once the invasive is controlled, the plan outlines strategies for restoring our native plant community through adaptive management, and a number of vegetation management tools are presented and provided depending on the outcomes of the curly leaf control. From that plan, we started in on our curly leaf pondweed control in April 2020 with an herbicide treatment. So as I said, curly leaf has come to dominate Como Lake. There's a map on the right. Is a biovolume map from early June 2019. Those red areas represent curly leaf infestation, dense curly leaf plants. So curly leaf was first observed in Como Lake in the early 90s, and now it's come to dominate 90% of the plant community. Curly leaf not only provides poor habitat for all the fish and macroinvertebrates living in the lake, it also is a huge source of phosphorus because once all that plant biomass dies off, it decomposes in the lake and releases the phosphorus back into the system during peak summer temperatures. When we have the longest days of the year, its typical senescence period or die-off period is end of June, so it coincides with the solstice and then also our hot July temps. So it makes the conditions perfect for algae blooms, smells, and then it also, through that decomposition process, lowers oxygen in the lake, which further drives our internal loading problems in Como Lake. Let's see here. So here's kind of a graph showing the life cycle of curly leaf pondweed. In each plant produces these turians, which are the reproductive structures of the plant. For lack of a better term, they're like a seed. Each plant produces over 100 and drops some off when they're mature in end of June, right before they die off. Those seeds look like little pine cones. They drop to the lake bottom where they take root and start growing in September. In October, the plants actually sprout. Come November, they grow underneath the ice. December through March, and then when our ice goes off in early spring and the light goes through the water, the plants all just take off. So you really see the impacts of a curly leaf infestation in May, because all those vegetation mats are floating at the surface of the water, and then they die off in late June, early July, again during those perfect conditions for algae blooms, and then it starts all over again. So but this also then, these plants are really aggressive in turbid water conditions. Also, they outcompete our native plants. So what we have in Como Lake is a situation where you have very few natives, and it's by early June, late May, early June, when those natives would typically start their growing season, they're already outcompeted by the curly leaf. So the native community is highly degraded in Como Lake. So addressing curly leaf is a huge priority for working towards our goals in Como Lake. So in April 2020, we did our first herbicide treatment of curly leaf pondweed. We used the herbicide Fluoridone, and we worked with the DNR and then a licensed contractor to apply the Fluoridone early season. We applied it April 13th, so shortly after ice out in last spring to kind of get a jump start since the curly leaf had been growing all winter. With Fluoridone, you need a low concentration of 4 parts per billion for 60 days. So we wanted to do it as early as possible to prevent any interaction with the natives that may come up in late May, early June. So here again is that graph. We applied early April, right as the plants are coming up, to hopefully prevent that whole growing season of the curly leaf from April to July. And the other, we didn't want the plants to mature any more than they already had. And as a result, if they're not able to mature, they're not able to produce the Turians, which again really drive the aggressive nature of this plant propagation in the lake. The next major project we did in 2020 was an alum treatment on Como Lake in May. And this project was intended to target our internal loading problem in Como Lake, which is a substantial contributor of phosphorus to Como Lake. This is our internal loading is legacy phosphorus that's built up in the bottom sediments since urban development began back in the late 1800s, early 1900s, and all those storm sewers got connected to the lake. So addressing internal phosphorus was really a high priority for starting to manage the excessive phosphorus problems in Como Lake. So in May 18th and 19th, 2020, we completed the alum treatment. All areas are over 6 feet or deeper in the lake were treated. So that resulted in about 58% of the lake having alum applied to it. This barge went out and injected alum about 6 inches below the surface of the water. And then when that alum hits the water, it flocculates and kind of forms a solid and then sinks to the lake bottom where it forms a blanket on the bottom sediments, which serves as a barrier for phosphorus being released from the bottom sediments up into the water column. So here's a map of the application of the alum. So kind of neat. Those are all the green area. That's the 6 feet depth or greater. And the barge blanketed these areas twice. Did 2 passes on the entire lake at these depths. So the results of the alum treatment were immediate. We had water clarity up to 6 feet deep right after the alum treatment. So and then the alum treatment, and I'll get into the results later, but it continues to work. It was effective throughout the entire summer, and actually the projected lifespan of these treatments are anywhere from 5 to 20 years. It kind of depends on your external sources of phosphorus that continue to come into the lake, the consolidation of the substrate or the bottom sediments. So we're monitoring it closely to document the longevity of this treatment and determine whether or not a maintenance treatment is needed in the future. Another major project that was completed in 2020 was a large-scale best management practice on the Como Golf Course. It was constructed on hole 7 on the fairway in July 2020, and this picture on the bottom, you can see this underground infiltration facility being put in. It captures over 744 acres of stormwater runoff. So this thing is very massive, and the estimated annual phosphorus reduction to Como Lake is 55 pounds per year, which is might seem small, but it's actually really, really large when we're talking about how much phosphorus is getting into the lake from these external sources. So this practice alone will get us that much closer to our will take a large bite out of our goals for external or watershed phosphorus reduction. This project was getting wrapped up last fall, and they're still working out a few kinks, and I shouldn't say kinks, but they're finalizing all the construction this spring, and this should be online in the coming month and fully functioning for into the future. One other project we did was that was identified in the plan and in the short-term implementation plan was a shoreline assessment, Como Lake shoreline. The shoreline was formerly turf grass right down to the lake shore. In the early 2000s, the entire perimeter of the lake was restored with native perennials for both all the water quality benefits of a natural riparian buffer, but also geese control. There was a huge geese and bacteria problem in the lake, and also it really just adds to the aesthetic beauty of Como Lake. However, it is a very, very comprehensive and extensive shoreline area, and now it's been going for over 20 years now. So we wanted to take inventory of the existing shoreline vegetation. There's a number of invasives that have come in. We wanted to identify erosional areas, quantify the wildlife habitat within the shoreline, and then identify areas for potential expansion if possible. And all of this is set to inform what something we're currently working on, which is a shoreline management plan that we're working on collaboratively with the city of St. Paul, since the Parks and Rec team is who manages the shoreline to really help prioritize and identify areas that we can invest resources in maintaining this great resource. In 2020, we also developed the Como Lake Fishery Management Plan in collaboration with the DNR Fisheries team. And this plan identifies long-term targets for a diverse and balanced fishery that complement the water quality goals in the Como Lake Management Plan. And it's also a plan to help support and sustain the recreational fishing opportunities at Como Lake, which are utilized widely by the community. So in short, Como Lake's food web, or all the fish groups, it's fairly dominated by bluegills. There are very few predator fish. So, and as a result, we've seen a large impact on our zooplankton community, which in turn is absent to help us out with our phytoplankton problem or our algae problem. So the whole goal is to kind of bring back some predator fish that are also fun to catch. So hopefully these fish trophic levels can self-sustain in the future and keep each other in check. Lastly, we've done quite a bit of community engagement. Again, even despite COVID, we did worked with the District 10 Community Council to do a lake cleanup event. Worked with the city of St. Paul to do this Dakota Waterways story stroll around the lake. We actively worked to promote the Adopt a Drain program. There's a number of residents within the Como Lake watershed that do that program. We developed a citizen science program called the Trash Data Project to promote trash cleanup. We're really active on social media. We also produced 3 project videos for the Alum project, the curly leaf pondweed management. And then we also developed these water wildlife stencils and signs as an engagement activity. You might see these this coming summer. There's stencils of these wildlife critters that are spray chalked onto the sidewalk, and then they're accompanied with some signage that give you a little information about that creature and their importance in our urban ecosystem. All right, let's get into the fun part, our 2020 monitoring data and results. All right, here is a graph that is showing total phosphorus since 1984. You can see the years on the x-axis. Our y-axis is our total phosphorus concentrations in milligram or micrograms per liter. Our blue line is hypolimnetic phosphorus concentration. So hypolimnetic is lake bottom, right at the sediment water interface, the lake bottom. And the red line is our epilimnetic, which is surface water. And then that green dotted line at the bottom is the shallow lake TP standard of 60 micrograms per liter. So you can see that concentrations of phosphorus in Como Lake have changed over time with lots of peaks and valleys. Starting in 2010, you see a major departure in kind of a cyclical trend that existed since the early 80s. And we've just had high concentrations since. You can see we've never met the state standard for TP. And then in 2020, we implemented these major projects with the alum treatment and the herbicide treatment kind of being the two major in-lake projects. See a massive drop in both hypolimnetic and epilimnetic concentration. So this is great news. We were really just excited to see this data and see these projects doing great work to reduce our phosphorus concentrations in the lake. For eutrophication parameters, which are total phosphorus, chlorophyll A, and Secchi depth, the historical averages for all of these 1984 to 2019 are extremely high and above the standard, except for Secchi depth met the standard for historically. So in 2020, the annual TP concentration was 65 micrograms per liter. So that is nearly met the state standard, just 5 micrograms per liter above the standard. So this is just incredible achievement to get to for Como Lake. And similarly, chlorophyll A reductions nearly met the state standard on just 1.7 micrograms above the standard. So this was great to hear, or great to see. And unfortunately, the Secchi depth did not, it meets the standard still, but there was no major change in our Secchi depth reading, which let me switch to this next slide to kind of show how that happened. So these are all of the sampling events we did in 2020. The yellow cells mean that the standard was met for that sample period. So you can see that 517 was the day before the alum treatment, and then 521 was the 2 days after the alum treatment. So you can see we went from 89 micrograms per liter for TP down to 26 micrograms per liter for TP just in the days following. And all 3 parameters kept up with or meeting the standards through late June, early July. And then come July, when things heated up and we started getting some algal turbidity, and that changed how the samples were meeting state standards. So that's kind of where or how we landed with that Secchi reading. Because of that algal turbidity, we kind of lost some water clarity at the end of the summer. This next graph is showing hypolimnetic soluble reactive phosphorus. So soluble phosphorus is, or SRP, is what really is being, or represents what's being released from the bottom sediments in Como Lake. And this is what's biologically available for algae to consume, and it's kind of our metric for gauging success of the alum treatment. So you can see that SRP has changed over time, with kind of 2013-14 being a peak in hypolymnetic, again, lake bottom SRP spiking. The long-term average of hypolymnetic SRP is 84 micrograms per liter. In 2020, following the alum treatment, we had an 87% reduction in hypolymnetic SRP. So this really tells us that the alum treatment did a great job at sequestering all that phosphorus at the bottom lake and prevented the release of it during low oxygen conditions. So this was really great to see. For aquatic plants, so following the herbicide treatment of curlyleaf pondweed, we observed a 56% reduction in total plant abundance. So these two biovolume maps are showing, well, the one on the left is the 2019, the June 10th, 2019, and the one on the right is our June 3rd, 2020. So same time of the year, and you can see the map on for 2020 is showing a massive reduction in curlyleaf plant pondweed abundance. So this was great to see. It tells us that our Fluoridone treatment worked and did a great job at preventing those curlyleaf plants from growing any more than they were once the Fluoridone hit them in April. As a follow-up to that, we did a Turian survey. So again, these Turians are the reproductive structures of the plants. They look like tiny pine cones. That picture on the right is our curlyleaf Turian. We did a pre-treatment survey in September 2019 of these Turians in the bottom muck of the lake. We repeated that survey this past September in 2020. And in comparing those two surveys, we saw a 79% reduction in our viable Turians in the lake bottom. So this was just really great to see. This tells us that we made a huge dent in that population, and we really are getting a good handle on those curlyleaf plants. And that was actually observed this spring. There weren't as many that, drastic reduction in what came back this spring. We did a survey as soon as ice went out, days following ice out, to see what plants were coming up, and it was a massive reduction in curlyleaf plants. So in summary, we had substantial improvements in water quality in 2020, with our annual average TP being 65 micrograms per liter, nearly meeting that state standard of 60 micrograms per liter. We had reduced algae with our chlorophyll A reduction, and we did see that minimal change in average water clarity, but we're keeping an eye on that and expect it to continue to improve as the lake kind of settles into each of these treatments. We saw a substantial reduction in the curlyleaf pondweed, as well as viable Turians. We did, through our plant surveys, notice a low observance of native plants that came back, which we're keeping an eye on and continuing to monitor. But we've been working with the DNR on that and have arrived at the conclusion that this is largely due to just extreme degradation of that seed bank and the native plants, since curlyleaf has been dominating for so long. So we're hopeful that future years, including this one in 2021, we'll see more native plants start to rebound following curlyleaf control. So how is Como Lake doing? The year one results, again, were very good. They're very good. We were just ecstatic to see those results come in. However, we're not totally in the position to claim victory yet. Those treatments are still settling into the lake, and I think their improvements are still yet to be realized from those. We'll continue monitoring in 2021 to further reveal the impact of these projects, as well as others that continue to get put in the ground. And I think the main takeaway here is there's no silver bullet to improving Como Lake. This is a living system with many different factors playing or at play. And it really takes this long-term commitment and cumulative approach to meeting water quality goals. We have to kind of do a lot of little things to hopefully cumulatively reach our goals. And that's why adaptive management really is key here. We need to work with this system and make incremental improvements over time. So next steps, we'll continue working through the actions in the Como Lake Management Plan Short-Term Implementation Plan this year. It was set for 2019 through 2021. And our plan for 2021 is, well, we did a spring herbicide treatment back on March 31st, just days after ice out. So that's been really successful. We're working on developing our shoreline management plan. We're implementing our fishery management plan and doing a number of surveys this summer to kind of really understand habitat and fish community structure. There's continue to be a number of watershed projects going in this year, as well as community engagement initiatives. So this fall, 2021, we'll assess our progress toward our goals and develop our next short-term implementation plan, the 2022 to 2024, since we're coming to the end of our first short-term implementation plan cycle. We're planning on working with our stakeholder groups to get that put together. So lastly, some acknowledgements. There's a number of people that have contributed to the Como Lake Management Plan, as well as our monitoring. They're all listed here. Limnocheck worked with us to develop the Como Lake Management Plan, and we've worked with them and WENC and a number of others to both develop and then implement this plan. So it's been a large effort of a lot of great work. So with that, I will open it up to questions, and maybe I'll just mention there's quite a bit of information on our website, and happy to email or call if anyone has any questions that don't get addressed outside of this this seminar. So.
All right, well, thank you so much, Britta, for your great presentation. We do have a couple of questions that have popped up in the chat.
Okay.
So the first one is from Laura. How does the check for Turians and the sediment not disturb the alum treatment?
Well, I think I guess the short answer is it does, no matter what, it is somewhat disturbing, that alum. Anytime, because the alum forms this barrier, I think of it as kind of this blanket over the sediments. Anytime we're scooping up sediment or disturbing the bottom sediments, it is either moving around or kind of puncturing that barrier, so to say. However, we only, we have set survey points. I can't remember, I think there's about 20 survey points, and those really, cumulatively represent a small area of, a minuscule disturbance when you consider the entire area of the lake bottom. So it's just kind of the nature of doing that type of sampling, unfortunately. So, but we're confident that the rest of the lake and having that in place, it's really the total area. It's kind of a minuscule impact on the overall treatment.
Great, thank you. We have another question here from Suzanne. Will the herbicide treatments need to be repeated annual or at least every few years?
Yeah, so we have a 7-year variance with the DNR right now to implement vegetation management, and the goal, we're the plan is to continue doing annual herbicide treatments until we get down to at least 15% frequency of recurrence of those plants. We acknowledge we'll never eradicate curly leaf from Como Lake. Once curly leaf is in a system, it's there to stay, and the best you can do is keep it under control. So right now we're making great headway on the curly leaf, and we repeated the treatment, a whole lake treatment this spring to kind of keep our foot on the gas pedal with getting a handle on it. But this is, where our monitoring data is really important. We'll continue to collect data this summer and then evaluate next winter whether or not this level of treatment is necessary for 2022, and so on and so forth. So we're really using our data to inform how we proceed with management of that. So.
Great, thank you. Another question here from Laura. How was climate change, more intense rains, longer stretches without rainfall, and higher temps factored into restoration of native species for shoreline, fisheries, and vegetation in the water? Are those species resilient to the anticipated changes in the climate?
Yeah, that's a great question. We've, climate change adaptation is baked into this plan. Inherently by it being an adaptive management plan. But in all of those, these kind of sub plans or like our fisheries management plans and the aquatic vegetation management plan, we have been looking at climate resilient species and hoping or trying to think ahead to warming water in Como Lake, increased chloride concentrations in the lake, etc. How are we factoring that into how we're supporting the ecosystem? So, I think it's definitely a part of how we're making decisions about, what plants are and fish are being supported in the lake.
All right, thank you. We have another question here from Steve. What is the difference between the current external total phosphorus load and the optimal TP load needed to meet the 60 micrograms per liter lake standard? And are alum treatments going to be necessary in the future, or can we manage external loading to the level necessary to meet the standards?
So the TMDL calls for 60% reduction in watershed TP, and based on watershed models, we're at about 20% right now. With that golf course BMP getting put in, I think that ups us to about probably 25 or 30%. So we're slowly getting there. One thing that's a challenge in the Como Lake watershed is it's fully developed. So a lot of, we can't just put in, we kind of have to wait for opportunities to put in these large scale BMPs. So it's very incremental. We can't just immediately get to our 60% here. I mean, it's taken us 20 years to find opportunities to get to 20% and to, the 20 to 30%. So we'll keep chipping away as opportunities come up. We have a couple big projects coming down the pike. So those will continue to get us towards our goals. And I think, we want to continue doing watershed work to help maintain that longevity of the alum treatment. The better you maintain external loads or reduce them, the longer your alum treatment works. So that is the goal. But again, it's a challenge when you have 22 storm drains coming into the lake. So we are monitoring the treatment, and we'll do a maintenance treatment if needed. But the best we can do. We can't really put a timeline on that yet. We just need to monitor and see when that's needed. So, but there is, yeah, it's in all the back of our minds of a maintenance treatment for the alum treatment as needed. So.
Britta, I thought that was really an interesting talk. Really, it's inspiring to see what you've been able to accomplish in Como Lake in really such a short period of time. It's really fabulous work. One question I have for you is, what do you see as maybe the most challenging part of the project so far? From your point of view, what has been the most difficult to get off the ground and implement in terms of all the stuff that you've been doing?
Well, I think, let's see. I would definitely, I feel like right now is kind of the easy part of doing implementation of these projects. The hard part was probably the plan development, because Como Lake is just, you know, it's this high visibility resource with many different stakeholders involved. We have between our agencies and our community. And I think also everyone has a lot of different expectations for the lake. Like you said at the outset, Mark, you have a special connection to the lake, and I think you plus 5.4 million people. And so everyone kind of wants Como Lake to do everything or one particular thing. You know, we heard a lot of people wanting it to be a swimming lake, for example. So it's trying to meet everybody's expectations, but also keeping in mind what's appropriate for a shallow urban lake, keeping expectations at bay, because there really is, you know, limitations to what is possible for Como Lake. So we've really tried to beat the drum of, you know, this of it being a shallow lake. It's not going to be a swimming lake ever. It was never meant to be a swimming lake. And let's be realistic, there's a huge contributing watershed. There's a lot of stormwater that flows through this lake. So let's focus on the goals that we can actually achieve, and instead of the ones that are kind of out of the realm of possibility. So expectation management for sure.
Great, thank you, Britta. We have one last question here, if we have just a few seconds to answer this one. Are park maintenance personnel trained about the impact of their work on lake water quality?
We work very closely with St. Paul Parks and Rec staff, as well as Public Works, and yeah, their maintenance staff are heavily involved in all this, the lake management. So whether it's, I wouldn't say it's a exact training versus just direct involvement and communication. And I think, you know, maybe that's been another challenge throughout all this is just communication. Is there's with so many people involved in the lakes management, making sure everyone is on the same page all the time, and fostering relationships across agencies and municipalities, make sure we're all kind of on the same, working toward the same thing. So I think that's was a great part of the Como Lake Management Plan development, because everyone got to be heard and have their input put in. And now they get to see how their input is getting put to work. So yeah, I'd say there's a really great communication happening there now.
Great. I'll just, give one shout out that we do have the turf maintenance for reduced environmental impacts training class. So if you are ever interested in getting those folks trained specifically on how to reduce their impacts from their use of fertilizer to maintain nearby parks and other grounds, we do have that turf class that has been fairly popular with that audience. So something to consider. Well, thank you so much for joining us today and sharing your work on Como Lake. It's great to hear from our local partners who are doing really great things out there. So I'm really glad you had the time to spend with us this morning. Maybe you needed the break from packing and moving, so you appreciated the time of working. But thanks again for being with us today. We really appreciate it.
Thank you, and thank you to everyone for listening. Really appreciate it.
Yeah, thanks, Britta. That was really great talk.